Well, be back, guys. This is Teacher Edward taking us through applied mechanics or applied mathematics. Under the same theme, which we are still looking for mechanics, and the topic is components and resultant of force. Components and resultant force. We are on example 3, which is saying ABC is an equilateral triangle. ABC is an equilateral triangle. The forces of 12 Newton, 10 Newton, and 10 Newton acts along AB, BC, and CA respectively. Then the direction of the forces being indicated by the order of the letters, the direction of the forces is being indicated by the order of the letters. Find the magnitude and the direction of the resultant force. Let us first sketch our triangle. We have this is our triangle. Make sure I use a straight line. So you have AB, C, ABC. Then I've said forces 12 Newton, 10 Newton, and 10 Newton acts along AB. AB here there is 10, 12 Newton, and then 10 BC, which is 10, and then what do we need next? It is another 10 along the CA, which is 10 Newton, 10 Newton, 10 Newton. So they have said the order of or the direction of the forces are being indicated by the order. If you are moving from A to B, since we move from A, B, C, the order is in that direction. That for the first force acting for 12 between A and B is in the direction of A to B. So you have to indicate the direction of A to B, B to C, and C to A. So this is our direction. And another thing you should note, since it's equilateral triangle, it is having the same angle, which is 60, 60, 60. That's the angle acting. So this is our forces. They are 3 forces. If you have 3 forces, we use the other identity, which we had, except for the other one of the bearings. So these 3 forces we have, they need us to get the magnitude. We know that if you have such kind of forces, this one is the horizontal, but these two are having 2 components, vertical and horizontal. So let us start with this one. So let us start with this component. If we take the vertical component of these forces, this one will go up and this one will come up, down. So vertical components, we shall have 10 going up and then 10 coming down. So our vertical component of forces will be vertical components of forces, which I get. This one is not having a vertical component, this force of 12 Newton. We are only having these 2 forces, which is acting in this direction. This is the point. This one is going downward and this one is going upward. So the vertical component will be here, which is 10. Let this one be force 1 and this one be force 2. The vertical component will be force 1 sine the angle, which is here star, even here there is theta. This angle is here. So our angle is here. This is the angle theta. So if it is to make 60, even here it will be 60. Even this one will be 60. So Our angle here it is 60. This one also is 60. So it will be F1 sine of 60, and then even this one will be F2 sine of 60. But since they are moving in different directions, this one will move upwards and then this one will go downwards. So the overall vertical component will be this F1 sine of 60 minus F2 sine of 60. So that will be the overall component. So here now on getting the component, we say now for 10 vertical component we shall have vertical component, let us have it as E y is given by 10 sine of 60 minus 10 sine of 60. For this one is moving up and then we subtract for this one moving down. So after that one we shall have the vertical component as this one. If you see this one is the same as this one, so our vertical component it will become 0. So we shall have 0 Newton, or we shall have 0 magnitude of vertical component. So we come on horizontal components. Horizontal components. So we have horizontal components. This one will move in different directions. So our sketch will be here. When you are getting the horizontal component, this one is moving to the right for 6, this one for 12 Newton, and then for 10, this for 10 will be to this side, and then this one will be, since this one is moving up, its vertical component will come this side. Also this one, they will be moving the same direction. So this one is here. All of them, they are acting at 60. This one is 60 degrees. Then if you put it this side, it will also be on. This one is acting upward, this one is going downward. This one will come here, downward, acting at it, also 60 degrees. This one is force. This one is moving upward, it will become 10 degrees. I mean 10 Newton, one is moving downward. But if you take this point here, for this one, or if you take this point here, this angle here is the same as this one, which is 60. That's why you are seeing me putting it there. Then this force will go downward because its direction is facing downward. So we are getting horizontal component. Now horizontal component, we shall get this 10 cos, since this one also is 60. From here, even this one is 60, even this one is 60. So we shall have 12. Our vertical component, which is f of x, equals to 12. 12 is not having any angle because it's on horizontal. Why do we put angles? Because we are trying to bring this one to the horizontal. And we said when we are bringing it to the horizontal or to x-axis, we use cos. So this one will be 12 minus. This one and this are moving in the same direction, we add them. We saw how we were going to do those forces from previous lesson, that this one minus this one and this are in the same direction. Why are we subtracting? We are going to get the total minus this one. Or we can first do one at a time not to confuse you. So for x and x, for 10 Newton, horizontal component, is given by 10 sine. Now since it is horizontal, it is 10 cos 60 plus 10 cos 60. this one become 20 cos 60. So this is the horizontal component for 2. Now we have this component which is the overall one, which is 20 cos of 60 minus the other component which is 12. Minus the component which is 12. That is 10 cos 60 minus the component which is 12. So, the overall horizontal component fx is given by this one, which is 12 minus 20 cos of 60. This 20 cos of 60 is the same as, if you get cos of 60, it's a half. So it will be 20 times a half. So which is 12 minus 10. This one equals to 2 Newton. Then the horizontal component is 2 Newton. They told us to find the magnitude and the direction. Told us to find the magnitude and the direction. Then this one becomes our f of y. Our f of y is upward, and this one is f of x going this side. This one is f of y. So we say that our resultant become in the middle here, which is f resultant f. So this one is our f equals to, so it is at an angle star. Our f equals to fy squared plus f of x squared. This one is the same as f equals to square root of f of y squared plus f of x squared. So our f of y, our f equals to f of y, it is 0, plus f of x squared, which is 2 squared, under square root. This one become f equal to 2 Newton. 2 Newton. So implying that the resultant force, it is on the same line, which is the horizontal. So this angle is 0. So the direction of the angle, direction theta of f is 0 degree. So that's how you overcome in that one. The first thing is to sketch. After sketching, put the direction, and then it's sort of vertical and horizontal, and then you find the magnitude. So that's where I end for today. Thank you for attending.